Amides can also be reduced in a similar way to any of the other carboxylic acid derivatives. They are, however, the one functional group that does not reduce to an alcohol. Now, as with any of the functional groups in this section, we need the stronger reductant LAH. And as with many of these mechanisms, what we show here is kind of a simplified mechanism. What's really going on in solution is probably quite a bit more complicated. But mechanistically, this reaction, at least in the beginning, behaves in much the same way as the other acid derivatives. The H minus, and as we have in the past, we put that in quotes because it's not really a free H minus, but LAH behaves as if it is H minus. But that attacks the carbonyl, and we shift electrons up onto oxygen. What was the carbonyl becomes coordinated to the aluminum. Again, we've added our hydrogen in here. And we've come to typical tetrahedral intermediate. What's very different about this mechanism from a lot of the other acyl substitution mechanisms is that our next step is to have the nitrogen add its lone pair in and completely kick out the oxygen that was our carbonyl. If you think back to a lot of acyl substitution mechanisms, this is usually the point where the oxygen adds back in and kicks out the leaving group. But because of the lone pair on nitrogen, this reaction takes a different pathway. This forms an iminium ion. And from here, another one of those H minus equivalents attacks the carbon of the iminium ion. And as a result, we actually end up reducing our amide all the way to the amine. So what the reaction really looks like, it basically looks like that you've just gotten rid of the oxygen from the carbonyl. So unlike all of the other carboxylic acid derivatives, including acids themselves, but carboxylic acids, esters, anhydrides, acid chlorides, and even some of the other carbonyls, aldehydes and alcohols, all of them, when reduced, will typically end up with an alcohol. Amides, because of this different step here in the middle, we lose the oxygen, and the amide gets successfully converted into an amine.